So this is a matrix that includes all the important concepts that we need to learn in physics, concepts, definitions, laws, equations. And there are 60 words here that you need to complete. If I clear all these words, you should be able to complete this matrix easily and therefore understand all at once the laws of physics and the laws of nature. So I'm going to go through this matrix very quickly, and I will erase the words gradually so that you are empty at the end of this lesson. I'm going to leave these two words till the end because these are very important. From here we get all the laws. So something moves in a system, we call it variable, and something pushes. Cause and effect. This causes this motion, right? For example, on Earth, a difference in gravitational potential or a difference in height pushes a mass. A difference of pressure in water pushes a volume of water. For example, in the circulatory system, the heart. A difference of pressure in the air pushes the volume of air in and out of the body. A difference of temperature pushes heat from hot to low, from high to low temperature. And a difference of voltage pushes charge. Once we accept these two definitions, all the other definitions are very easy to understand, and they are just a relationship between these. So the first concept is the concept of resistance. What is resistance? Are what allows and opposes to the motion of bodies. In mechanics, we call it friction. All right? I'm going to delete friction. Bodies, a volume of water is moved through arteries, veins, pipe. What allows and opposes to the flow of blood, we call it arteries, veins, pipes. In air, it's the same. Pipes or nostrils are the path for the air. In heat, fire, heat can go through earth, we call it conduction. We can go through fluids, we call it convection, or it can go through space without any resistance, and that we call it radiation. And finally, what allows and opposes to the flow of charge in electricity, we call it resistance, and it's Ohm's law, voltage divided by current. Now, let's go to the next concept, the concept of intensity. Intensity, symbolized with I, means motion of the variable in time. In mechanics, it's the motion of bodies. In hydraulics, it's the motion of volume, that means the flow of water. In gases, air, it's the flow of the air, wind. In heat, it's the flow of heat, joules per second, which is also power. And in electricity, we call coulombs per second the current, amperes. So motion in time, done. Now, in blue, I talk about the same concept, one with words and then with a law. I want you to pay attention to this. The symbol is E, and the unit is joule. Energy, by definition, is what a system uses to work. So in mechanics, we call it gravitational, hydraulic energy, aeolic energy for air, solar energy, and electric energy or electromagnetic energy. Now, what are the equations? Pay attention to these. The laws are equations, right? A law is an equation. So the equation for gravitational energy is the mass multiplied by the potential difference, and we call that gravitational potential energy. If I multiply volume with pressure for air, for water, that is known as hydraulic energy, pressure times volume. The same thing for gases. Pressure times volume gives us joules. That's known as Boyle's law. There is a law that connects temperature with heat, and that's called Newton's cooling law. More difference of temperature produces more heat coming out of the body. And the law that connects charge and voltage is known as Joule's law, and it's known as electric energy. So what is the equation for electric energy? This multiplied by this. All the equations are very similar, and that makes a lot of sense. A new concept, capacitance, the ability to store and release the variable. For example, in mechanics, if we have a mass hanging from a spring, the spring has the ability to store that weight and stretch. That is known as Hooke's law or elasticity. Water, we cannot compress water. If you want to increase the pressure of water, water transmits it. So water is incompressible. There is no capacitance in water. Water is not used to store, but it's used to transmit energy. So for example, our lungs are compressible. They expand and they store air. They increase the volume, they increase the pressure and the more volume goes into the lung. So air stores energy and water transmits energy. The blood transmits energy. The lung stores the energy from the air and then transmits it to the blood. In physics, the ratio between heat and temperature, that means the ability to absorb heat and increase temperature, is known as heat capacitance. And in electricity, the ability to store charges and increase voltage is known as the electric capacitor, tanks that absorb and retain charge and therefore increase voltage. So that is the concept of capacitance. Power, by definition, is rate of work. So we have mechanical power, hydraulic power, pneumatic power, solar power, and electric power. And the equation for power is energy divided by time. So if you divide mass by gravity by height divided by time, you have force and velocity. Force and velocity is the equation for power. A similar equation is for water, pressure and flow of water. This is like velocity and this is like force. Pressure times flow makes the power of water. Similar or exactly the same is for gases. Pressure times flow means air power. This equation explains how a plane or a bird can fly. Power in thermal physics is definitely just energy over time, the variable divided by time, because energy is what comes from the sun for us. So power is solar power and is heat divided by time, and electric power is charge multiplied by voltage divided by time, therefore voltage multiplied by current. If we look at these equations again, they're very similar, right? Force, two factors make power. One that is force, the other one that is motion, velocity, pressure and flow, well, charge over time, definition of power. And here we have current and voltage, very similar, right? Voltage is similar to pressure and current is similar to flow. So now we have an empty matrix. There are 60 words here. 60 words here. There are some, I'm gonna erase this also. These definitions are also erased. Goodbye. So now we have an empty matrix and you have to complete this matrix and submit it to me. And you get 1 seat for each correct answer. Therefore, you get up to 60 seats if you get it all right. But also you get a lot of extra seats if you submit first, second, or third. So time is crucial. Good luck. These are the words in disorder, disorganized words and concepts and equations, and you need to put them in order here. That is the game for today's lesson. Go for it.